Live. I think we're almost live. I think we're live. Okay, great. Awesome. So, all right, we got one person watching. Hello. Okay, so let's jump into this. I'm just gonna do question 7, and then from there I'm gonna just ask that you work on these questions independently. So let's work on question 7 together. So this is about a function that we're calling g. So this is the function g, whose graph is given. So this is the graph that they're talking about. So this is the graph y equals g of x. Okay. So state the value of each quantity if it exists. If it does not exist, explain why. So we'll kind of take a look at some of the reasons why a limit might not exist. And we might take a look at why some of these values don't exist. Okay, so something to be aware of is that sometimes a limit does not exist. Okay, and I'll talk about some of the reasons why. Okay, so yeah, let's take a look at. Oh gosh, there's one more thing that I haven't shown you. Okay, I apologize deeply. I need to cover one more thing before we jump into these problems. Okay, so please be patient with me. One more little fact that we need to talk about, which is one-sided limits. Okay, let's talk about one-sided limits just for a second. Okay, so a one-sided limit, approaches a value from either the left, or the right. I can't believe I forgot to tell you about one-sided limits. Okay, so it approaches the function either from the left or the right. Oopsies, what did I do? There you go. Okay. So let's go through here and talk about some of these one-sided limits. So this is how we describe one-sided limits. So we say I'm gonna talk about the left-handed limit first, and then I'll make an analogy to the right-handed limit. So limits are either one-sided limits can either be from the left or from the right. So I say that the left-hand limit, the left-hand limit of f of x. Yeah, let me just zoom out a little bit. Of f of x as x approaches a. Okay. Is equal to L. And I write it like this, written the limit as x approaches a, and we put this little minus sign as an exponent. It kind of looks like an exponent. It's not an exponent. It's just a little symbol that we put here. So the limit as x approaches a from the left. So this little guy means from the left. From the left. Okay. Okay, so that means that we're approaching a from the left. Okay. If we can make, this happens if we can make f of x arbitrarily close to L. Oh, and I forgot the rest of it. Sorry, I'm a little flustered because I forgot that I hadn't shown you this definition already. So yeah, we say that the limit, the left-hand limit of f of x as x approaches a from the left. Oh my goodness, you'll have to apologize. I'm not sure what's wrong with me right now. From the left, from the left. Yikes. From the left is equal to L. And that's written, so the limit as x approaches a from the left of f of x is equal to L. And that happens if we can make f of x arbitrarily close to L by making x sufficiently close, but less than a. Okay? So it's saying that we're only going to be approaching a from one side. Okay? So x is going to be strictly less than a, but very close to a. Whereas the regular limit is kind of both sides. We're looking at it from both ends. Okay? Okay, so the right-hand limit, I guess I can make this a little bit bigger. There we go. The right-hand limit is analogous to the left-hand limit with x greater than a. Okay, so it's the same thing except we're approaching from the other direction. And there's one little fact that we should be aware of. Okay, the limit of a function at a, I should say of a function as x approaches a, exists if and only if the left and right hand limits are equal. Okay, so x has to approach, or f of x has to approach the same value regardless of which side we're approaching it from. So for example, if our function looks something like this, and here's our value a here. Okay, so if our function looks something like this, whoop, and then it picks up down here, whoop, okay, so that's what our function looks like. Okay, let's kind of name a few more of these values. So let's say that this is, let's call this, I don't know, how about t, and this is s, okay? So it looks as though, just by looking at this function, let's call this function f of x, I know that we've got a few different things going on here. So f of a, in this case, is equal to s, okay? And I know that because this is filled in, right? This is a filled in circle. This is an empty circle, okay? But there's another few things that we need to notice here, that the left-hand limit, okay, you can see that this is approaching the value t, right? So the limit as x approaches a from the left of f of x, that's equal to t. But the limit as x approaches a from the right, that's how we write the right-hand limit of f of x, that's equal to s, okay? So since s is not equal to t, we have that the limit as x approaches a, sometimes we refer to that as the two-sided limit, right? Because we're approaching it from both sides of f of x. It does not exist. Okay, sometimes we write d and e. Okay? So in order for a limit to exist, it has to approach the same value from the left and the right. Okay? So it doesn't matter if one of those exists, but then the other one doesn't, or if they both exist and they're just approaching different values. We have to make sure that they approach the same value. Okay? So let's try this question again. And I lost my book. Just give me 1 second here. There it is. Okay, so let's take a look at question 7. Boy, I'm a mess today. I think I know what it was. A family member of mine thought they had coronavirus, and they just got a test, and they texted me like an hour ago saying that the tests were negative. So it's like, yeah. So I've been a little on edge today, and like I'm just kind of a little bit hyped up. Whew, yeah. Yeah, good stuff. Good stuff. Yeah. All right. A little flustered, a little disorganized, but let's try to get them back on track. So let's go over these questions. Let's take a look at question 7. So we'll take a look at the first one, question 7a. So we're taking a look at the left-handed limit. The left-handed limit. So in this case, our variable that we're looking at is t, right? So we've got a t-axis, right? Which is fine, right? There's nothing wrong with the t-axis. That's usually what we refer to as time, right? So this is our, often we refer to that as our x-axis, but who cares? It can be any letter. So we're saying that t is approaching 0 from the left, okay? And we want to know what that limit is. So here's my function g of x, and I can see that kind of around here. It goes down to 0 over here, okay? So if I'm approaching from the left, I'm going to be on the left-hand side, right? So I'm approaching it from this direction here. So I can see that as I go from the left, oh, there it is. Okay, it looks like I'm approaching this value right here, which I believe is -1. Okay, so this is going to be -1. Okay, so that's equal to -1. Okay, so the next one. What happens when we approach from the right? Well, if I approach it from the right, well, I'm going down here. Whoa, okay. And from the right on this side, looks like I'm approaching this value. Now you can see here that this is an empty circle. So I'm not actually equal to that value, right? But the limit is such that I'm going down here and I'm approaching this value right here. So that looks like a -2 to me. Equals -2, because that's where I'm headed, right? This third one here, this is when the limit is, this is the two-sided limit, right? So I want to know what is our function approaching when t gets very close to 0? So yeah, it doesn't approach anything, right? Yeah, it's approaching two different values depending on which side of the tracks you're on, right? So this value here, when t is equal to 0, you're going to have two things going on. On one side, we're getting -1. On the other side, we're getting -2. So does not exist. Okay. Let's try another one. Let's go to -2. Or sorry, +2. But we're going from the left. So +2 from the left. Okay. So +2 from the left, right? This is the value t equals +2. Looks like on the left, we're approaching 2. Approaching +2. And if we go in from the left, or sorry, from the right rather, from the right, okay, we're going from the right, looks like we're hitting 0. This is equal to 0. Now, if I approach it from both sides, well, I think that we can see that it's not actually approaching any particular value. So this does not exist. All that said, we can evaluate our function at 2, and we get yet another value, because that's what this solid dot is for. So remember, these empty dots say that we can get as close to that number that we want to, but we won't actually ever like land on it. Same with this one. But this is saying that this solid value says that this is what the value actually is when t is equal to 2. So g of 2 is whatever this value is. I believe that's 1. So g of 2 is actually equal to 1. So imagine that. We can evaluate a function in 4 different ways, right? We can evaluate the limit on the left, the limit on the right, the two-sided limit, and then evaluate the function just as it is. And in all of those ways, we evaluated the function to get different values, okay? One of which does not even exist. Yeah. Mm-hmm. Mm-hmm. So these are our values of 2, right? Or so these are our values of t. When t is equal to 2, right here, and I want to know how far up and down am I going, okay? Well, when g is equal to 2, I'm looking for something solid on here, right? Which is this value right here. Yeah, because it's not equal to 2 because there's an empty circle here, just like there's an empty circle down here. Okay, so this is a solid circle, which means that this is what the function is actually equal to at that point. Okay, but the empty ones are saying we get awfully close, but we never actually hit it. Ah, good question. So this is an example of a function which we will learn all about, which is called a discontinuous function, which means that it's kind of scattered all over the place, right? My guess is that this is some kind of piecewise function, right? So maybe this is like some parabola, right? But we've kind of cut the parabola off and sort of erased all of this. Maybe this is like some kind of maybe it's a cubic function, right? Or there's some maybe not a cubic function. Maybe it's even maybe it's a sinusoid. I don't know. But then they've only cut it off here and here, right? So it looks as though this is some kind of combination of other functions, right? Okay, so finally, let's take a look at the limit as t approaches 4. Limit as t approaches 4. Okay, looks as though as we approach it from the left and we approach it from the right, it seems to be approaching just this value. Nothing weird is going on, right? There's no tricks. This isn't a trick question, right? Okay, so as we approach 4 from the left and 4 from the right, it's just this value right here, which is 3. Okay, so no tricks. No tricks. Oops, where did I go? So this is going to be just equal to 3. Okay. All right, I'm going to end the video there. I'm trying to keep my videos nice and short, so that's 17 minutes. Bye-bye. And